We're very lucky to have Peter Wang here with us today. I could go on and on about his bio, and we'll get into all of it, but we'll center some of our discussion around the Conda open source project, of which Peter was one of the creators. So, Peter, thanks for coming on the show.
Thanks for having me, Eric. Excited to be here.
As is customary, tell us what Conda is, although we won't limit ourselves just to Conda today.
Yeah, so Anaconda is a system, a software distribution that we built many years ago to make the open source data science tools around Python much easier for people to install and update. And Conda is the package manager tool inside Anaconda, and it's a package management format. You think about sort of like if you use RPM on Linux, right? It's something like that. And the wonderful thing about Conda is that it is cross-platform, so you can use it on Linux, Mac, or Windows. And it actually supports more than just Python. It supports R, it supports C++, any number of different languages. So we built the system. It's one of these stories where we built it as sort of a accidental side project, in our quest to make Python more powerful and better and easier to use for data analysis. We sort of had to make a way so people could actually get all the tools. And so we built this as sort of like, hey, let's do this thing to make it easier for people to install everything. And then it's the thing that became really, really popular. Now, a lot of the tools we built also became very popular, to be very clear. But certainly Anaconda and Conda are now a staple in the data science toolkit for many millions of people around the world.
I got my start, in open source in data science, and I got my start in data science on Anaconda and Conda.
Great.
I think everybody has the trouble setting up their Python environment the first time. That's like the getting started. Like that's how they screen people, I think, for the profession. Is like if you can't, and it's not about wit, intelligence. It's like patience. If you can't get through this and feel comfortable, and Conda solved a lot of those problems for me. Or Anaconda did. You already kind of alluded to why you needed this. I should mention to our listeners, we had Travis Oliphant on earlier, and he kind of teased at the need for package managing in Python, that it was hard to kind of distribute libraries. And eventually he realized that was kind of one of the most important aspects of the ecosystem. You mentioned this as well. Tell us how you got your start and what led to the development of Anaconda.
Yeah, so I fell in love with Python as a programming language starting around 1999. And so I've been reading over the course of several years. I've seen it come up on Slashdot. And then finally in 99, version 1.5.2 was released. And I said, okay, fine. I'm going to go and actually play with this language a little bit. And I played with it and I fell in love with it. I was like, this is amazing. So I kind of used it as a side tool, for a number of years. And then in 2004, I got a job really that was at the intersection of many of my many things that were interesting to me. So I got a job doing scientific programming using Python as a consultant. And so I used Python and NumPy and SciPy and all those tools at the time. Actually, 2004 predates NumPy. It was still called Numeric and NumArray at the time. There were two different competing libraries. So I did that for a number of years. And then towards the end of the aughts, and that's actually where I met Travis initially, was at that consulting company named Enthought. And we had a wonderful time there, a lot of great people. But towards the end of the aughts, both of us came to realize that Python has a much bigger and brighter future than merely sort of a consultant's tool. And at the same time, it had some challenges, some missing pieces that were sorely needed if we really want to take it to the next level. So I started the company with Travis in the beginning of 2012 with this mission of rounding out some of the things that were needed in the Python ecosystem. And then really just showing up as a vendor to say, look, Python's great. You don't have to use Hadoop for big data. You can use Python for really scalable big data. And you don't have to just use R for doing statistical processing. You can do Python statistical processing. And so we sort of showed up in a time, and now it's quite ubiquitous as a tool. It's the most popular language for data science, certainly. And it's, depending on who's counting, it's possibly one of the most popular languages in the world. But back then, it wasn't obvious at all, right? I got a lot of flack from people who are like, why don't you just use R? Or what's wrong with you? Java's clearly won. I mean, you look at all these Apache projects for big data. Java is the thing for big data. And I would say, well, I don't know. I think Python's pretty good. So we showed up sort of as kind of the weird kids on the block, pushing all the, a bunch of science people, right? And at the time, Jupyter was called IPython at the time. The right. IPython web notebook had just come out. And Travis and I, we were friends with Brian, Fernando, Min, these guys who've been making the IPython project. And we've been pushing on them to make sort of a web experience, right? Because they had a rich client one, and we wanted to make a web one. They made this web one, and we said, look, this is the bee's knees. This is gonna be awesome. We didn't quite say bee's knees, but we thought it was awesome. We're not that old school. It wasn't that long ago. But we're like, this is gonna revolutionize everything. This is amazing. And so it was a bunch of ex-physicists, ex-engineers putting together these computational tools. None of us had a CS background formally. And then and then we just show up at the big data party. We show up, in various places where people are trying to use things like SAS and R, and we say, hey, try Python. And now 10 years later, I think those efforts have really paid off. So
yeah, I can identify some with this the kind of Java world and the Python. I was at the Strata conferences and the Hadoop conferences, and I worked on the MapReduce team at Google, and so I often was in the Java camp. And you're right. There was kind of there was this bifurcation. It was like we were talking past each other.
Yes.
And you probably feel like you were vindicated eventually, Peter. The world's kind of tipped towards Python, it feels like.
Yeah. I have a sticky note here on my wall, and it says, the only fairness in life is the justice we create. Or I'll state it differently, be the change you want to see, right? I'd done enough programming in C++ and Java to know that I enjoy doing Python a lot more when it came to data processing and scientific computing. And also to make it more serious, in those years that I was doing consulting, we're brought into the heart of Fortune 500, Fortune 50 companies who have all the budget in the world on IT and compute. And we would find scientists, teams of analysts. You go into like a JP Morgan or a Bank of America, and you have quants, and they loved using Python. There's something about an interactive read, eval, print loop. And this is even prior to the notebook, right? This is just people having an editor. Sometimes they're just using idle, and they would be able to think quantitatively, build little apps, run massive scale computations. And they loved that they could do all these things themselves without having to, do a big project with IT and with software developers. And that concept of empowering the domain scientist or the domain expert was really fundamental to Travis and my mission and why we were promoting the use of Python. Because we said, look, this is a tool that clearly fits in people's heads. And when you see the spark of joy on people's in their face and their eyes when they're able to wire something together and make it really work, that was something that we thought the world needed more broadly. So for all of the awkwardness and pain of Python packaging, there's an XKCD comic, right? About how terrible Python packaging is. That's kind of a level of infamy. There's like infamy and there's like XKCD makes fun of you kind of infamy.
Yeah.
But for all of that pain, at the end of the day, when it works, we have to keep in mind what it's doing is it's empowering people who are not software developers to go and do some amazing things that without it, what would they be stuck doing? They would be stuck playing around with Excel or trying to beat a bunch of MATLAB, cobble a bunch of MATLAB into something usable as a user interface. It's I do think that ultimately we've been very successful in moving the world forward to more usable computing for a more broader set of people.
Yeah, you're a champion for the everyman, and specifically, but specifically the domain expert, right? The people who can affect change if they could just put their ideas into action. And the barrier not only was the language, Python gave them a path, but then the barrier within Python seemed to be packaging or part of it, and how My naive view of the world is you first start on pip and then you get frustrated, at least when you're doing data science, and you end up in Anaconda. How did that evolve? Were they parallel? How did that play out?
Well, what's interesting about all this is the long sordid tale of how all this stuff kind of went down, if you will. So packaging in Python has been historically had been a bit of an afterthought. And so there's a system called distutils, which is how Python loads modules and packages. Then setup tools came around in the mid 2000s. And then it sort of got abandoned a little bit. And then people tried to fix some other things around it. Pip was written as a wrapper around setup tools to make it easier to use, kind of. And then it also, I don't think it got abandoned, but different people picked up development. And so it's just a classic case of like Band-Aids on Band-Aids. And one of the things that in talking to Guido van Rossum, the creator of Python, we've talked a little bit about this over the years. And he just is very transparent that he never really was that interested in solving the packaging problem. So he was just like always left it as someone else to do. He has an amazing quote. I think it was PyCon in 2017 or something, and he was at the Anaconda booth, or it was Continuum at the time. So he's at the Continuum booth, and we're just chatting. And he said, yeah, I really don't understand the whole packaging problem, because for me, whenever I needed something, I would just pull into the standard library. It's like, that's the solution that only he gets to do.
Yeah.
For the rest of us, the packaging system has been, well, I guess on a sort of less glib note, the reason why packaging in Python is so much harder and more terrible historically than in lots of other languages is actually because Python is more powerful in this regard. Precisely because the Python VM, the virtual machine that runs, the Python interpreter, it's a lot of users of Python don't really go below the surface of the ocean, but there's miles of ocean down there. And if you look at the structure of the Python VM, one of the things about it is that it's got a low-level interface that is not what your typical Python user would interface with. But if you write extension libraries and modules, you can interface with the VM at a much lower level. And it's very powerful. You can extend the types that are available inside the programming language runtime. So as an extensible VM, it was really powerful. And it's precisely because of this that we were able to wrap all of these C and C++ and Fortran libraries, right? The reason why the scientific community adopted the Python language so glommed onto it was because we could extend it like this. And the reason why Java has always had this it's always treated the scientific community as a second-class citizen is precisely because the JVM does not have this level of a thing, right? The memory management, the JITting, all these amazingly powerful things inside the JVM make it really hard to interface with native code. And so Python, it just it doesn't, because it has this connection, it makes it really simple. Now, the downside of that is now you got these extension libraries that drag in a pile of C++ and Fortran. And now the build system is horrible, right? But to be clear, if you look at something like Node.js, NPM is it kind of a god-awful mess of package management, and they don't even have to compile a bunch of C++ and Fortran.
No.
So I would say that the Python community as a whole has done kind of okay in, having shipped all of this really complex, gnarly stuff, kind of made it basically work. And what happened is actually I have this wonderful set of pictures from, actually we have it on video. We have it on video at the first PyData workshop in 2012 at the Google headquarters. And Guido was working at Google at the time. So he stopped by. We're about 50, 60 people just in the conference room. And we started, hey, he's here. We didn't know he was going to show up. He's here. Let's pull him on stage and do a panel impromptu. And some of us were asking him about, there were questions about number one, will you prove a matrix multiply operator? And eventually we got one. So that was good. And the second thing was we asked him, can you help us fix Python packaging? And then we have him on camera saying, look, the needs of the scientific and numerical community around packages may be so complex and esoteric that you're probably better off building your own thing than trying to sit here and not fight, but spend a lot of time spinning wheels with the kind of packaging efforts happening within core Python.
You may have no choice. It really sounds like your guys' needs are so unusual compared to the larger Python community that you're just better off building your own.
And so we said, okay, we take that as permission, I guess. And so that's one of the things that made us feel like we were, okay in building kind of alternative system for doing this. And now it's a very large community of people who use Conda, who build the Conda recipes, package up thousands of different kinds of libraries. Anaconda is actually not even involved in that stuff. We help, with the recipes on some of the things, but then we take those recipes, we build them on our secure hardware, right? And we put them behind our repository, which we curate. And so there's no typo squatting attacks. There's no whatever. We make sure that all these different libraries, when you install them, they actually work well together. We test them all together. So that's kind of the value of what you get when you use the Anaconda official repository. But we've always kept it a very open system, and we've tried to play well with the broader Python packaging community. But everyone's resource constrained is the part of the problem. It's all a volunteer effort. So anyway, that's kind of how we got to where we are now.
And fascinating. I mean, I don't think I understood that Python's its rise was coupled to this fact that it could mesh so well with legacy code and you know, the Fortran and the C++ libraries, and that superpower that made it so popular also made it kind of tricky to do the packaging. But good work.
It's a bunch of scientists and engineers went and modded this like cruiser into an aircraft carrier, and now and now it's all these aircraft carriers and all these planes landing on them. But the other part of it is actually, I think, another sort of subtle part of this is that the fact that we did have a packaging system in Python meant that you could democratize innovation. And this is a really important thing for the ecosystem. It wasn't just one group of people saying, we're going to build the de facto compute system, right? It's lots of people innovating in parallel, agreeing about certain kinds of interfaces for interop. And then that just allowed to kind of instantly in the space of a decade, completely take over numerical computation, right? Like everywhere. You couldn't have done that if it was just one small group of nerds, you know, in some office somewhere saying, we're going to build the world's greatest computing system. It just, you wouldn't get it done. So there's that's another thing that sort of pulls, or it's another driving factor for why there's a packaging problem. It's because there's so many people doing all these things in parallel.
Yeah, the decentralized organic evolution, as opposed to like a central planning exercise.
Exactly.
Top down. Yeah, fascinating. And so you set out, you know, years ago to put Conda and Anaconda into works, and then you've been at Anaconda since. And meanwhile, you've seen the rise of this Python community go from kind of the thing that's not R or Java that domain experts like to use to being the tool
thing. Yeah.
That the industry I mean, when, you know, TensorFlow was all written in C++, and when it came out as a Python.
It had to have Python on top, right?
Where does that leave us today? I mean, where's Python headed now? I mean, I suppose.
Yeah, that's a good question. There's still a lot of people onboarding and learning, right? I think it's funny when I talk to some folks, even smart, clueful folks, let's say in the venture community, right? And they look at a lot of technology. They've made bets in the past on languages. Maybe some have worked out, some haven't. Many of them still look at Python as sort of a language bet, and they miss the fact that it's a kind of a language bet, but it's kind of the language of a new professional class. And so it's wrong to sort of think about Python as in the frame of, is it Python versus Ruby or Python versus R or JavaScript? It's like, no, forget the computer programming CS nerd kind of people building apps kind of, you know, as software developers. Instead, think about quantitative computing. What do people use for quantitative computing? They use Excel. And so Python for a new class of people is becoming a tool to augment Excel, to augment Tableau, to augment the traditional business data analysis tools. So when you look at it from that perspective, this is, you know, you really have to understand the revolution behind Python as a people revolution, not a technical revolution. So the people revolution part of it is I think a really important part of my reasoning for my answer, which is I think Python's here to stay for a long time. Because the people who are doing this, they are not the kinds of people that are going to go and learn Haskell tomorrow because you can prove something about types. You know, they're not going to go and learn Rust because it compiles. Like, they're just going to, if they can bang out like a 10-line data script that kind of still works, they're good. You know, they've got lots of other stuff to keep themselves busy. And so I think and this is sort of, the point is a little bit proven by when you look at the other data languages, how long they've been around. What is the longevity of MATLAB, of SAS, of SQL? Right? These are other data languages for humans, if you will, right? As opposed to CS nerds. Yeah. And those things stick around for decades. So now that we've got a language that's basically good enough, there are going to be variants of it. So you look at like MicroPython for doing embedded, right? You'll probably see some additional variants to run it in the web browser as WebAssembly becomes more mature. There's all, you know, we ourselves have some thoughts about how to build maybe a slightly tweaked variant of Python that we can JIT compile faster, right? Or do autograd kind of things better on. But all these tools, at this point, it's just the shelling point that's so darn ubiquitous. It's really hard to imagine what could be so compelling that you will, you know, like cause tens of millions of people to instantly overnight change to something else. And if you can't convince all of them to change very quickly, the sheer gravity of all those users is going to pull those things back into that language, that syntax. And I think that overall it's going to evolve relatively slowly to encompass and grow a lot of these additional features.
No, you're absolutely right. The community, there are developers who know 5 languages. They feel comfortable in Ruby, and they'll bounce over to, as you said, Haskell or Go. But the folks who know Python, that's almost a career effort and kind of skill that persists, with them over the life of their career, and it persists within their industry. I mean, their industry is built around these libraries and frameworks in Python, and I don't see those going anywhere.
Yeah, especially if we're around to continue being a steward and shepherding a lot more great open innovation in this area. We're really coming to the end, I think, of the idea of shrink wrap software being like the primary value driver in the value chain. A lot of this capability in ML AI, which is clearly the cutting edge of where everything is going, right? All the software capabilities are being released in the open source. So people are going to basically pick up all of this stuff, and you have this massive open source commoditization wave that is going to, keep adding value to this skill for people. So it's really, I call it literacy. Python is the language for data literacy at this point. Obviously, SQL is another important one, and R has its adherence as well. And I don't want to poo-poo R. It'll be around for a long time as well. But ultimately, between Python and R and SQL, these are the components of data literacy. And that's going to be a lingua franca that every white-collar professional is going to have to know, probably 5-10 years from now.
Now, you mentioned, how we think about commercializing software, the business of software, and the role of open source. You had to make some decisions as you turned Anaconda into a business. How is that framed? Maybe you could share some of your kind of decisions around commercializing Anaconda and how you're seeing those types of decisions play out for the industry.
It's been a journey and a process, right? So we started back in the day. We started very honestly being like, hey, let's build some additional advanced libraries and try to sell those. People are kvetching about this is slow and that is slow, so let's make some fast things, and then we'll just sell the fast things, right? We're going to charge like $50 for them or something, and surely some hedge fund quant who's getting paid $500,000 a year can afford $50 for a faster Pandas or faster NumPy.
Right.
That theory did not play out very well. Turns out that the anchoring effect is real. Someone could get, if you really have them think about it, like probably tens of thousands of dollars of free value from open source. But if you ask them for an incremental dollar, it feels like you're poking them with a hot iron, right? They just somehow the human psychology and the anchoring is not great there.
Yeah, this is like the equivalent half hour of your compensation, and you'll fight it tooth and nail. Exactly.
I mean, in the time it takes you to tweet at me, how dare you charge for open source? You've already, you could have just paid us the money and then been good. And then we would have taken the money to build more great innovation, right, in open source and in the. But no, that didn't work out. That was circa 2012, 2013 timeframe. And then we built like a GPU compiler. We're trying to sell GPU compiler for like a couple $100, and people were not having it. And so some people, now to their credit, some people did pay for it. We really, I am grateful to those people forever. But ultimately, it wasn't going to scale. And then, of course, the open source community felt betrayed. They're like, you're taking all this open source stuff, and then you guys, big corporate fat cats with your Delaware C Corp, now you're making all this money. You're making like $200 off your source. And so it's like, that didn't play well with the community either. I mean, most people understood, but it's like there was still vocal people in the community who are very sort of absolutists about this sort of thing. So, and then, as big data rolled on and then ML started coming around, we start seeing all these companies around us raising tens of millions of dollars building on open source, just like taking scikit-learn, taking NumPy, Pandas, Jupyter, and rolling them into, I would say they put relatively shallow veneers, thin veneers over this bundle of things, and they would go and raise really a very large sum of money and sell their offerings at a very high margin, and then not give anything back to the open source community either. And so you're like, well, that's not great. Like, that can't be the way this goes, right? Because I like to tell a story that I'm friends with many open source developers who write these foundational libraries. And I know that these libraries power literally billions of dollars of value at every single FAANG company, right? Every single one of these companies. And the problem is that these developers then, they're literally doing this as a side gig. And I don't want to call anyone out by name, but I'll say that one of the most popular visualization libraries possibly in the world, the lead developer, he has to do it as a nights and weekends gig. He has a full-time job as a staff scientist at a national lab. And that's just a damn shame, because I know that there's that, I won't even name it, but every single Silicon Valley startup that uses any kind of data science uses his library. And they should be paying him at least $100,000 a year for the value they get. But they don't.
Or
right?
on the contrary, think of all the value they could benefit if he were given a little extra time to work on this thing.
Well, if he and the people he identified who were aligned with the values of the project and could do good work, the craftsmen ultimately, right, that could do this. I mean, maybe we should make open source, maybe we should put open source code onto the blockchain as an NFT. Well, I guess it's a Git, so it's already a blockchain. But if you could wrap up each release as NFT and you bid on it before it got cut into a release, I don't know. But the idea here is that these people are artisan craftsmen building incredibly thoughtful work, getting paid nothing. Meanwhile, people who had nothing to do with it take it, bundle it up, put a veneer on it, and then raise hundreds of millions of dollars. And so I looked at this and I said, this isn't great. I don't begrudge the people who build good businesses raising money. That's fine. But it's like, this is not sustainable economics for this community that I care about, right? And I've been an open source nerd since like 95. So I started the Linux users group at my college. I was on the Slashdot bandwagon the whole time, I think XBill was my screensaver for a number of years on Linux. So I was a classic open source nerd, but by the 2010s, I realized that open source has got to actually figure out a way to make money sustainably and honestly to put regenerative economics back into the ecosystem, right? So that's really where Travis and I had a lot of discussions and thoughts about and Travis, to this day, right, at Quansight, what he's trying to do with open teams and many of these things is to really think about what is a fair OSS and open teams, a lot of these things. He's trying to think about how do we align the economic incentives of network collaboration with sort of the standard market capitalism sort of economics, right? That's a hard question. It's one that actually we face as a species, because a lot of things that we do in the business world today are deeply extractive and not good. Right. So you have sustainable investing as a real movement now. And I'd say that we're in our own way trying to figure this problem out for the open source community around software. So where we ultimately got to last year was I said, I think what we could do is we can charge for value. We turned on a commercial repository for packages. We looked at successes like Red Hat, which was very successful in building a commercial package repository and charging people a fair price for timely updates to secure, timely secure updates to signed packages with security guarantees around them and things like that. Businesses know what that's about. Free users can still have access to the free stuff. Like it's all great. So we essentially went to that same model. And so with the package repository, we have the community package repository that's free for everyone to use. We have our own, we have a commercial one as well that then the commercial users should be using. If you're at a big business over like 200 people, you should be using the commercial repository. The price is not onerous. It's basically $15 a month. And in volume, it's even lower than that. So we tend to do ELAs with big businesses. And the value is clear, right? It's going to cost you like $100 a year to have a data scientist be productive and not waste a bunch of time trying to fight with packages. And meanwhile, you have an actual vendor to call. And when you get audited, you can say, well, let's see, on our customer protected data, we're running actual software from a vendor versus rando packages from the internet.
Yeah.
So it seems like kind of a no-brainer. And so we have been actually selling pretty well with that. And then we also, in conjunction with that, we announced our open source dividend program. So this year we're putting 1% of our revenue. We're going to just write that as a check, essentially, to the open source community through the NumFocus Foundation. And my goal, and really sincerely, my goal is to increase that percentage as we go forward in time. So 1% is a small number, but it's a starting point. I mean, Google and Apple don't do it, right? But I will. So that's kind of what we're doing now with that.
That's fantastic, and it's an exciting time. You mentioned we chatted before the show just briefly, and you mentioned that there's been some big exits, companies who've had an open source association that have created, as you mentioned, this kind of wall of capital. I mean, there's a lot of fundraising now around open source, and it's kind of unproven as to whether this is all going to amount, we're going to see a whole wall of exits or not.
There'll be an exit one way or another.
Yeah. But it's an opportune time for us to kind of figure out how the economics of open source can work in everyone's favor, and you seem to be kind of at the bleeding edge of figuring that out.
I think one of the things, again, I really do believe we're kind of coming to the end of the era of software being that big margin driver. And so if people are able to use the open source software adoption as a way of pivoting themselves or bootstrapping themselves into a different kind of business model, the most obvious being cloud, right? So if you look at the database companies, Elastic, Mongo, these companies, they use open source as a way of getting a lot of developer attention. So the scarce resource that they're actually stockpiling is developer attention and knowledge of APIs, and then of course production deployed services tied to those APIs. They're able to then pivot that into essentially a SaaS business model.
Yep.
There are other business models that you can turn this kind of developer attention adoption into. So we're doing something, I would say related, but different. I think that actually for us, we're closer to something like a Roblox, where it's a developer and it's a maker, a creator community. And it's a sharing network, right? It's an ecosystem and network marketplace. And so that, just to be completely candid, in my conversations with potential investors over the course of the last year as we've been embarking on this particular strategy, people seem to grok it 60% of the time.
Yeah.
I mean, they still want to apply SaaS revenue metrics to it, but they kind of get like, hey, that's kind of interesting. But that's still kind of unproven, right? And so, yeah, it's a little bit bleeding edge, but look, we have a massive user community. And so our job right now is to activate that community, get them sharing, connecting with each other, putting some more economics into it for everyone. And then once that stands up and really gets going, I think people understand, people who are classic down the fairway, like spreadsheet investors will be able to look at a spreadsheet and say, okay, I get how all these metrics tie out. But I think that's really the problem that open source suffers, is that for a long time, people don't quite know what kind of platypus is it, right? Because you look at it in one way, you say, well, you're giving away all your IP, so there's no defensible IP. This isn't worth anything. Then smarter investors are like, wait, hold on, but you're getting a ton of users. If you turn into a SaaS business, your metrics are great, right? And so that's where your database companies exit. And then I think the next generation is going to be looking at not even the open source of it as much as just how much traction do you have, how much usage do you have, and then converting that usage into what kind of monetizable economic energy, right? So if it's a marketplace, what's your VIG? If it's a straight up pipe, then what is, how much velocity you're getting through that pipe and what's your cut of it? So I think, I think that we really are in at the very beginning. I really like James Currier at NFX. He writes a lot about, enterprise gateway marketplaces. That's what we are right now with our commercial B2B side. But then when you look at something like Roblox, I really see that as being, a touchstone of kind of what I think the AI, data science, and machine learning creator community could be. And certainly Anaconda is the platform for that.
And Roblox is not a bad comp.
It took a number of years, but hey, man, not a bad comp. Not a bad comp.
My understanding is during the pandemic, they doubled, usage. All the kids weren't in school and flocked to Roblox. Unfortunately, I don't know that everyone all flocked to their Python notebooks, but maybe they did during the pandemic.
We have seen usage grow tremendously during the pandemic. A lot of people picking up data science, a lot of people taking advantage of all the downtime they have at home. Right. And the lack of travel time. They're like, well, I'm going to go and do this data science thing.
Yeah. Time to upskill.
Time to upskill. So we're definitely seeing that, that growth last year. I mean, it wasn't like a Zoom-like growth, but it's been continued sustained energy in adoption and stuff. So I'm very pleased, and I think that we're really just the beginnings of a really interesting ecosystem and network activation.
Well, and you have a unique view on that. You're the cradle to grave is maybe not the right term, but you see people when they learn Python, and you see the professionals that are hammering
right.
on every day.
That's right.
And you can watch their progression, and you can see where the community's headed.
Yep. Yeah. It's really it's really kind of weird, like being able to just being the package distributor, right? We sort of can see a lot of trends around different cloud services. We can see trends around what are people actually using versus what gets hyped. We see a lot of different kinds of trends. It's very interesting.
Peter, as we wind down here, I want to give you a chance to tell us where Anaconda's headed, if there's any details to share, and also how people can get involved in the work that you're doing, if any of this is, excited them.
Yeah, well, so Anaconda is, I think, really headed on a great trajectory. I'm very excited about what we'll be doing this year. I sort of already previewed for you kind of like the strategy of what we're doing. We're revamping a lot of our offerings to really orient towards this creator community marketplace and helping creators and users connect better. Also having a role for vendors, right, for commercial vendors and businesses to plug in. So really excited about that. We do have a number of, I think we have 14 open positions right now. So would encourage people to look. We're hiring for everything from data science to DevOps, across the board. And we are a very remote friendly place. And we'll continue to be moving forward. It's not just because of COVID. We're pretty remote friendly even before that. So that's where Anaconda is headed. And also, if you don't want to necessarily work for us, you can work in the community. We have a lot of open source projects around visualization, scalable computing, data access, and so many other projects in the community. I just encourage people who are active users to think about how they can sort of be more makers in the community. Start a blog, start a podcast, publish some of your notebooks, do some analysis and post on Twitter. Just do more of that making. I think that makes the whole community feel more participatory and more accessible. And that's a really wonderful thing. So that's it.
Awesome. Yeah, just a plus one what you said about contributing on multiple levels. I don't think people realize the power of evangelism. Projects will win and die not on technology, but on the ability for others to communicate the value and the vision, and that can be somebody on YouTube and in a blog post as much as anything.
Yeah, and it's really, data science is a global phenomenon. I've spoken in India and Japan. I've spoken to PyCon Taiwan, and what's amazing is this really it's kind of a beautiful, almost enlightenment ideal sort of thing of quantified rationalism, kind of being empowering people across the world. And so, in particular, right now in the data sciences, I think a lot of the innovation in the open source stuff is very kind of Western Eurocentric, but the usage is global. And so it can actually have this weird effect where people who are not in the kind of Eurozone and kind of Western countries, they may feel like they're a little bit of imposter syndrome, like, should I publish my blog or whatever? And I just want to, if anyone is listening to this podcast who is in like not the Eurozone and the Americas, like if you are in one of these other countries, I would strongly urge you to please actually tell your story. Please publish your work about doing data analysis relative to problems in your area or in your sphere, right? It is a global community, and we want a global conversation across all of the different economic areas and language and cultural zones. So just to really want to emphasize the diversity there around that.
Amen. What a great note to end on. Thank you, Peter, for your time. Good luck.
Thank you, Eric.
You can find today's show notes and past episodes at contributor.fyi. Until next time, I'm Eric Anderson, and this has been Contributor.